Hello everyone, my name is Kassy. I've been interning here at Google Sydney for the past 12 weeks. I'm here to give you a presentation on web platform feature metrics. The first day I arrived to the office, I came to my desk and found a couple-page document that my manager had put there for me. It read, Objective: to measure real-world usage of features of the web platform and provide an easy way to query and display this data. With this sentence alone, I knew instantly that I had a big and exciting project ahead of me. And here we are, 12 weeks later. I've completed my internship and put this presentation together so that everyone may have an opportunity to learn a little bit from my experience. In this presentation, we will hit a few points. We will talk about why this project is of interest not only inside of Google, but also outside of Google. I will go over how we gather data in Chrome using user metric analysis. I'll talk about the necessary changes in WebKit to measure the use of CSS properties. We will get to see a preview of a dashboard that I made from scratch in App Engine. And finally, we will talk about the technical knowledge I gained while building these dashboards. Why this project is of interest inside of Google. As a browser vendor, we want to make sure that we are adding useful features to Chrome. The adoption of a feature is concrete data that gives us insight as to whether or not a feature and property is being useful across the World Wide Web. If a feature doesn't gain wide adoption, then we know that it's not worth dedicating resources towards to support. Also, a big part of supporting features is maintaining them. As usage is high, we know to put high priority on the maintenance of that feature. Sometimes, the usage of a feature might significantly decrease over time. An example of this might be when a prefixed CSS property is standardized. Over time, we would watch for when the usage of the prefixed version decreases. And when it's no longer used significantly, we can deprecate that version of the property so that we are no longer dedicating resources to supporting two versions of the same property. In addition to being of interest inside of Google, this project is of great interest outside of Google. Well, with data regarding how widely a feature is being used, developers can have more insight to the likeliness of a feature to have continued support across various browsers. With this data being openly available, we are enabling developers to make informed decisions on their own so that they may decide for themselves what properties and features they should and should not be using in their own websites. With this data, we may easily detect and bring to light new features that are on the rise. We can further help bring these features to developers' attentions so that they can keep their web pages using new technologies. And last but not least, this data is also useful to other browser vendors. It will help them identify when they need to start supporting features because of the increase in adoption of that feature across the web. So now that we've established that there's great interest inside and outside of Google for this data, how are we going to gather the data from Chrome? The answer is UMA, which stands for User Metric Analysis. If users opt in to UMA, the Chrome client will send a log of aggregated UMA data to the UMA server approximately every 5 minutes. These logs provide us with information, such as how often a user uses the back, forward, and home buttons. We can see how often bookmarks are added and how often tabs are restored. We can also use UMA data to record information about the websites that are being viewed. As we parse a web page to display it to the user, we can measure the web features which the page is using. One of the web features currently being measured is HTML5 tags. And I've recently added measurements for CSS properties and IndexedDB API calls. The primary focus of my project was on CSS properties. To measure the use of CSS properties, I needed to edit WebKit code, since this is where the CSS parser lives. While implementing these measurements, I wanted to make sure that I counted each property only once per page, because there are many properties, such as color, which can be used countless times on a single web page. One of the biggest challenges I dealt with was the identification of CSS properties. Within the browser, we identify a CSS property by an integer ID. The challenge is that this integer ID can vary across each release of Chrome. I had a couple options for enabling the mapping of these stable IDs. One option was that I could do the mapping on my dashboard. This would have the benefit of being on the server side and not impacting the user. However, this implementation would be very complicated and time-consuming to pursue. So I was on to analyzing the second option. The second option was to implement the mapping in WebKit. This implementation would not be as complicated or time-consuming. However, it would be on the client side, so it would be more crucial than ever to keep performance in mind. I found that the mapping for all CSS properties averaged at a total of only 39 microseconds per page. This is a very small number in respect to the total page load time, and thus would not be a cause for concern. As a start into my project, I implemented usage measurement and some simple dashboards for the IndexedDB API calls. We are still gathering enough data on the CSS properties for those graphs to be interesting. So what I will share with you today will be a preview of the IndexedDB dashboard. We will start by seeing some snapshots of my version 1 dashboard, which were oftentimes quite funny and instantly taught me a lot about analyzing data. Here's a snapshot of one of the first graphs I produced using UMA data. As you can see, there are 3 points on this graph, which are highly likely to be inaccurate. Lesson 1, verify that your data is correct. Through a bit more research, I was able to find the source of the errors in this data. The data processed and returned through our UMA pipeline has overflow buckets, which I was not accounting for, and thus I was interpreting the data incorrectly. Once I was parsing the data correctly, I received a range that was much more predictable. I found that over a period of a month, transaction was always between 93 and 97% of the total calls made to IndexedDB. However, when I use an axis that focuses too closely on the 90th percentile, it gives the reader the impression that the usage of this API call is fluctuating dramatically, which simply isn't accurate. As you can see in this graph, the very same data with a wider range on the vertical axis gives us the perspective that the data is fairly steady with little fluctuation. What we can take away from this is as we continue measuring web platform metrics, we need to be cautious in the way that we display the data so that it is interpreted correctly. And now we will see a preview of the IndexedDB dashboard. We have 3 calls that are represented here. Transaction, which we have gone over, is obviously the majority of the calls that are made to IndexedDB. Open, while not used as frequently as transaction, is also a significant call to IndexedDB. And create object store, as one might predict, is used not very often at all. It's less than 1% of the total calls made to IndexedDB. However, its use is fairly steady as well. And finally, we arrive to some of the technical points that I learned while building these dashboards. Once I had read the data files from UMA's cloud storage, parsed them, and stored them in my data store, I had to analyze different methods for reading the data out of my data store and getting that data to the JavaScript where I could insert it into the Google Charts. The method I decided to use to accomplish this was using XHR, an XML HTTP request. In total, I could use App Engine's GQL query class to get the data from data store into my Python, where I could write it into a file. Then I would perform the XHR request from JavaScript to get the data from that file where I could use it in the Google Charts. I quickly learned that doing multiple XHR requests can have a great negative impact on performance. So, on a dashboard where I have 2 or more charts showing different data, while it might be convenient to do a request for each set of data, it is necessary to get all the data that I can within a single request and then distribute it to the appropriate charts. Also, while I was developing the CSS dashboard, I went through multiple iterations and was able to see the performance improve over time. At the beginning, I tried storing data in Data Store the same way it was stored in UMA's cloud storage. This was not ideal because I would perform calculations and conversions every time that a chart was loaded. As my project began to take more form, I shifted to a model where I would run updates automatically each night. When I collect a new day's data, I would do the conversions and calculations before storing the data in Data Store. Then, when the chart is loaded as a user visits the dashboard, minimal processing is required, and I can simply display the data that I receive from my Data Store. Ultimately, I would be doing necessary calculations only once per day, and it would never be on the user's time. So thank you all for your time today. A point for you to look forward to is that the CSS dashboard is expected to be live on chromestatus.com in late April. Also, feel free to contact me via email, kassycoan@gmail.com, or my Google+.